Hey geometry students. I thought this was a really cool application with cosine, and so I wanted to show you guys this. This is called the cosine effect error, and it's used really with police radar. I thought that was kind of neat. So I'll read this part to you. You'll also see it on your worksheet, but it says police microwave and laser radars measure the relative speed of vehicles approaching or receding the radar. If a vehicle is traveling directly at the radar, the relative speed is the actual speed, so there's no error. If the vehicle is not traveling directly at the radar, like if they're traveling at an angle to it, the relative speed is slightly lower than the actual speed. And that's called the cosine effect, because the measured speed is directly related to the cosine of the angle between the radar and the vehicle direction of travel or speed vector. And it says here, the greater the angle, the greater the error, pretty much. And the lower the measured speed that the radar will end up detecting. So, if you look at this formula here, right in here, it says measures speed, that the radar actually measures the speed, and it kind of shows you, here's the radar, and here's the line of sight. So let's say this particular vehicle isn't right in front of the radar, they're at an angle to it, okay? And so here's the cosine effect angle. It's really right here. You know, if you're looking at the radar, the angle is down here. But remember, with parallel lines, these are alternate interior. So here's another angle you can look at as well. That's the same angle, okay, if these are parallel lines right here. So we've got, it's saying here in this one, we have a target speed. The person that is speeding, they're called the target. So that's their speeding. So that's their speed here. So that's the target speed. That's their actual speed, basically. And then there's the angle that they are relative to the radar. And then that's the measured speed that the radar will detect. Okay? So again, VM is measured speed. VO is like the actual speed, it's the target speed. And then that's the angle that the car is to the radar. And you can kind of see here beta, I think they messed that up, but it's supposed to be beta because that's what that is, a little b. So beta is the cosine effect angle. And then they give you some other things in here. The target range to the radar. So this is like, here's the car. That's how far it is to the radar in the horizontal direction. And then this is the distance to the middle of the lane that the vehicle is on. Okay? So anyway, we're going to use this, just this right here. We're just going to use VM equals VO cosine B. We're just going to use that. Okay? So, let's say, I'll just give you an example, and then I'll have you guys do a couple of these. All right, so let's say, if you look right here, let's say that it says the target speed was 85 miles per hour on I-10, and the cosine effect angle was 15 degrees. Okay, and then it says, what was the measured speed? Okay, so I'll show you how to set that up. So on here, remember, if we have this, it's VM equals VO, I guess, if you want to say that. It's the actual speed, cosine beta. So that's our formula. So it's saying the target speed, the actual speed, was 85. So the 85 would go there. Okay, so that's why on this formula here, I have 85 written where the V naught is supposed to be. So 85 goes there. And it says the cosine effect angle was 15 degrees, so that's why I put a 15 there. So it's 85 cosine 15. Okay? If you plug that in your calculator, you're going to get 82.1 miles per hour. So this particular vehicle is only measuring 82.1 miles per hour, even though they're going 85 miles per hour. Okay? So again, that kind of makes sense because it said back on the previous page that the measured speed would be lower than the actual speed. Okay? So now we're going to do another one. All right, so just changing it up now. If the measured speed was 50 miles per hour, add that in there. If the measured speed was 50 miles per hour and the cosine effect angle was 40 degrees, then what was the target's actual speed? Okay, so if I set this one up, this time, again, the measured speed we were given, that was 50. We were not given the actual target speed. And then we were given the cosine angle, beta. So if you set that up, that's 50 equals V naught times cosine 40. Or 50 equals the actual speed times cosine 40. So in order to solve that, if we come over here, 50 equals V naught cosine 40. If I divide both sides by cosine of 40, right, I'll get the actual speed. So 50 divided by cosine 40 ends up being 65.27 miles per hour. So notice, again, this is the target speed is higher. It's the actual speed. It's higher than the measured speed, which was 50. Okay, measured speed is always going to be lower. All right? Let's see. Last one. We'll do one where it is relating to the angle this time. Okay? Then I'll give you ones that you can do. If the measured speed was 70, okay, so that the measured speed, remember, is lower than the actual speed, and the actual speed was 80, that makes sense. What was the cosine angle between the radar and the target? Okay, so this is a little bit different. So now we're looking for an angle instead. So we were given, if we look back up at this equation up here, Vm equals V naught cosine beta. If we look at that again, this is the actual speed, measured speed, actual speed, and then the angle. So again, the measured speed was 70, so that's why it's on the left side, because it goes where Vm goes. And then equals, and then we've got the actual speed's 80, and then we have cosine beta. We don't know what beta is. So if we divide both sides of this by 80 to solve for cosine beta, we'll end up with cosine beta equals 70 over 80. Okay? And then remember, in order to find an angle, if you don't have the angle, you have to take the inverse of cosine in order to get the angle. So we have to do the angle then, beta, I should say beta here. Beta ends up being inverse cosine of 70 over 80. Make sure when you do this, your calculator, your online calculator, is in degrees. That's a tricky part. Sometimes we forget to change it back over. It's usually set in radians first. So make sure you change it to degrees. But that ends up being, if you put that in correctly, you have to press the inverse button and then the cosine button and then put in 70 divided by 80. It'll end up being 29 degrees. Okay, so you should be able to do all three of these types of problems, and I'm going to give you 3 different problems to try. Okay, but I hope you enjoyed learning about that because I thought it was very interesting.